We are going to move things a little out of order right now, guys, and we are actually moving to Unit 8, and we're going to go back to Unit 7, just because I felt like a lot of this will be reviewed. For example, the Pythagorean theorem. We've already done this, right? We use it to find the missing sides of a right triangle. Sides. Well, let's try that again. The A and B sides, so the two sides that make the right angle are the legs. This is all review. C, that last part across from the 90, is the hypotenuse. And it's for any right triangle, right? And it is a squared plus b squared equals c squared. We've done this before. So, for example, in number 1, we are missing what is across from the 90. So we have our A and our B, right? And I will, 8 times 8 is 64. 169 equals c squared. Go ahead and add those. We get 233 is c squared. And remember, when we are doing this, we are not dividing by 2. We are taking the square root, something completely different. So square root, in this case, of 233. Type that into your calculator. And I get a decimal, so I get 15.26 in this case, or 15.3, just depending where you're rounding, right? Number 2 is just like number 1. Let's look at number 4. Notice we have the side that is across the 90. So in this case, it's 19.1 squared plus x squared equals 30.5 squared. And we use a calculator because we have decimals on this case, so I do want you to use a calculator to make sure you get an accurate answer. So 19.1 times 19.1, that is 364.81 plus x squared. 30.5 times 30.5, 930.25. Now we have to subtract over the 364.81. So minus 364.81. X squared is 565.44. And again, we're going to take the square root of that. And x is about 23.8. This time I chose to round to the nearest tenth. So it just depends where you're deciding to round. For number 6, I just want to give you guys a hint that it is 2 shapes, right? If I break it up, I have a rectangle on this side, and I have a triangle over here. If this blue part is 5, this blue part is 5. And if the whole thing is 18, you can find out that other leg right there. Go ahead and give that a try. For number 5, I just want to give you a hint. If the left side is 24, that means the right side is 24. It looks like a 9. There we go. The reason they put this dotted line is because that dotted line is going through the middle, so I know each part is 11. And then you can use the Pythagorean theorem, right? Number 7, you've seen something like number 7 before. Again, you have 2 triangles. You have one right here and one right here. So you have to do the Pythagorean theorem twice in order to solve for x. I'm not going to go over much of this because you've done Pythagorean theorem, and so I feel like you guys know how to do this. So I'm going to go ahead and leave you guys at practice. What I am going to move to is this, where it says the Pythagorean theorem and its converse. So we know the Pythagorean theorem, right? That one is a squared plus b squared equals c squared. I'm going to put the c on the left this time, though. And you're going to see why here in a second. But it means the same thing. So we have a right triangle. But let's say if we do the math and c squared comes out, oh, that's really bad, greater than a squared and b squared. Well, that means I have an obtuse triangle. And if it's less than the sum of the a squared and b squared, that means I have an acute. Obviously, C is just always going to be whatever the biggest number they give us. So in number one's case, 9 is my C. So 9 squared. I don't know what symbol I'm using, so I'm just going to put my bridge, is 3 squared plus 7 squared. Okay. 9 times 9 is 81. 3 times 3 is 9. And 7 times 7 is 49. I'm going to ignore the 81. I'm going to do that math on the side. On the other side where it's 9 plus 49. And that should be 58. And I still have my 81. Now I'm going to put in my symbol. Which one are they equal, less than, greater than? Well, I know 81 is bigger than 58. So in this case, I have an obtuse triangle. Then let's look at number 3 right below it. We have 16 is our C. So we're going to leave 16 on the one side. And 4 and 11. The reason I'm not putting the squares is because I want you to notice 4 plus 11 is 15, right? Remember when we were talking last unit about, or 2 units ago, I apologize, possible triangle sides, the sum of the two smallest has to be bigger than the largest. So in this case, I do not have a triangle at all. So I need you guys to pay attention to that. They're throwing some of that review back in there. Number 5, I'm just going to do the full left side. Let's see here. What is my biggest side? It is 30, and I know 18 and 24 is greater than 30, so I'm going to go ahead and just go straight into it. 30 squared, putting my bridge because I don't know what symbol I want. 18 squared plus 24 squared. So I'm going to go ahead and do all my squares. We get 324. And we get 576. Bring down my 900 on the left, add my 2 numbers on the right, and I get 900 when I add. So this is an equal to, which means I have a right triangle. Okay, last one. 39 is my biggest, and 31 and 35 I know is bigger than 39 when I add, so I can go straight into building. Oh, squared. Okay, 39 squared is 1,521. 31 squared, 961. 35 squared, 1,225. I'll just bring down my 1521, haven't done anything to that. I'm going to add my right side together, and I get 2,186, which in this case, I can't see that very well. Let's change my color. I will use a less than symbol because my c squared is smaller than the sum, which means I have an acute. Go ahead and give that right side a try. Again, double check to make sure that your 2 smallest sides add up to be bigger than that third side. Most of it is pretty obvious. And then go ahead and make sure you build it, you square your things, and then evaluate if your c squared is bigger, smaller, or equal to a squared and b squared put together. Let me know if you need any help. I'll be happy to come over and answer any questions.